Hi, 7th class. Today we are going to learn about the presence of mineral in water. See, we said that water is having high dielectric constant. So all the substances will be dissolving in it. So getting a pure water in the nature is very difficult. You want to check whether minerals are there or not, impurities are present in it or not. We'll take a beaker, put some water, and we'll take a watch glass, and in that watch glass we'll put some tap water or natural water. Then we will be heating it. On heating, when all the water is evaporate, we will get that watch glass will be getting this type of rings on it. Why these rings are formed? Because these rings are formed from those minerals which are found in the water. Similarly, we said, now what is the importance? Why these rings are there? So what is the importance? Water acquires the taste from these dissolved salt. If you boil water and remove these minerals, you will see that water tastes flat. Dissolved salt acts as micronutrients which are required by plants and animals. We are also drinking water to fulfill our mineral needs which help in the growth. Now we will be doing an experiment and trying to see that whether air is present in water or not. Air is dissolved in water, we know. Oxygen is there, carbon dioxide is there, all the fishes, animals living in water, and plants doing the exchanges of gases. So to prove that, we will take one conical flask, round bottom flask, and in that we will be putting some water, and then we will be heating this water over there. We'll see that it start producing bubbles, and on this side inverted jar is there. On inverted jar we are having trough, beehive shelf and all that. So we'll see that after some time the water in this jar will start moving down. Why? Because something is traveling from here to here. You can see bubbles coming over there. So these are the gases which were present in the water. This experiment proves that there is gases dissolved in water. Now what is the importance of these gases? These gases which are dissolved in water are used for respiration for aquatic plants, animals, and these gases also kills germs and bacteria. Now carbon dioxide is there. It is used by aquatic animals for doing photosynthesis, and there are large number of other animals who use this carbon dioxide for developing their children. Now we will be learning about solution. Now substances we dissolve in water. Water is a solvent, we know, universal solvent. So a solution is formed when some substance is added in water. So a homogeneous mixture of solution in a solvent is known as solution. Solute is a substance component which dissolve in the solvent, we call it solute. And now normally solute is always present in smaller amount. Sugar solutions, salty solutions, and all that like thing. Solvent is the component in the mixture which is present in large amount, in which other things are dissolved. Like sugar solution is there, water is acting as solvent. Now the solutions can be divided into two groups: aqueous and non-aqueous solutions. The solutions which are prepared in water, we call them aqueous solution. Like sugary water, salty water is present in them. Now there is one more type of solution known as non-aqueous solution. Solution prepared in any other solvent, not water. We call it non-aqueous solution. Alcoholic solution, ammonical solution. If we are dissolving alcohol, substance in alcohol, tincture iodine is there. Ammonical solution, when substance are dissolved in ammonia solution. So this is one classification, at aqueous solution and non-aqueous solution. Now there are solutions on the basis of concentration. It indicates the exact amount of solute dissolved in the solvent. Concentrated solution is the amount of solute dissolved where no more solute can be added now. Like 40 gram of sugar in 100 ml of water. A dilute solution means a small amount of solute is dissolved as compared to 40 gram. If I am dissolving 10 gram, 20 gram, means 20 more I can add. A solution in which more solute still can be added, but small is added. We will be calling it as dilute solutions. Dilute acid, concentrated acids, we do it. Concentrates, we are getting Ruafza and others. Yes or no? Then we got saturated solutions. A solution in which when we are adding solute, one time will come when no more solute can dissolve. We'll say that solution has reached a condition where no more solute can be added. Saturated solutions. Now there is an activity how to make a saturated solution. We'll take a beaker. In that beaker we'll take water. In that water 100 grams of water we'll start adding potassium nitrate in it. 1 spoon potassium nitrate, then I'll stir it properly. Then 1 more gram I'll say it will dissolve slowly. Then I will be adding. After a stage will come when no more nitre will dissolve. If I'm adding 1 spoon, it will not dissolve. I can see it at the bottom of the beaker. I'll say that solution is said to be saturated at that given temperature. Now what is the effect of cooling on saturated solutions? If a temperature is lowered, solubility of the solid decreases. A part of dissolved solute starts separating and I can see the salt settling down at the bottom of the beaker. Unsaturated solution is a solution in which more solute can be dissolved at a given temperature. There is one more definition coming, supersaturated solution, a solution in which solute is added more than its capacity. Means saturated solution is formed and after that also I am adding more and more in that. So that type of solution I call it supersaturated solutions. चाशनी देखा है हलवाई को बनाते हुए. So that solution is supersaturated solution. Okay children.